range. But anybody remember what the domain represents? Virginia? Yes, if my smart bird works. There we go. So she said it's the x values from like one number to another number on the graph. So we'll just say all x values where the graph is defined. So generally when you're doing domain, you look at the left, and then you look to see where the graph goes on the right side. So all those values from where it starts to stops for the graph. So that means the range that Virginia would be the? Right. And when you're looking at the y values, you want to look at the bottom of the graph and kind of move to the top of the graph. So from the small number to the larger number. The last term is a function, and if you go back to that time we had that the quiz on the iPad and everybody hated it, and I swear I can never do it again.
I liked it.
Sam liked it, okay. Function was one of those definitions that a lot of people missed. And then I think I threw it back on like the chapter 2 test to kind of solidify the importance of remembering what a function is, how it works. So there's two different ways like to think about a function. One would be graphically, and the other one would just be kind of like internalizing or recognizing what the ordered pairs are representing. So Sam, do you remember what a function is? Or how to decide if something's a function?
Shoot. No. Oh wait, y is equal x. I don't know.
Well, it does have to deal with y and x. Ethan?
There can't be same x values.
Right, so you can't have that same repeated x value. So we would say each input or x value has exactly one output or y value. So specifically, you can't have a repeated x. But then there was a test that we did. And if I had the graph, page. Yeah, so it would also have to pass the vertical line test. So the vertical line test is when you draw those vertical lines, and you can only go through your graph once. If it goes through more than once, then it's not a function. And that deals with the same thing that Ethan said, where you can only have one x value, because if it's going through your graph twice vertically, then there are multiple x values, or the same x value for the multiple y values of the graph. All right, so underneath, there are 3 pictures, but I want to change the first one just by connecting the dots, so we're not really changing it, but I want to make it be a continuous function. So connect the dots for the first one, but not the second. So one example with separate points is enough to look at. So we'll make this into a v. If it's a v, does anybody remember what equation goes along with the v, Kate?
Oh wait, no, it's absolute value.
There you go. Good catch there. So if we connected this to make it a v, or in this case an upside down v, this would become then an absolute value graph. So that it has a little bit of more of an interesting domain and range to talk about. So first off, let's go to the function question. Is this a function? Does it pass the vertical line test, Ethan? Yes, so it is a function, it passes the vertical line test. So then when we're thinking about domain, we said all the x values where the graph is defined. So x goes left and right. What would we think for the domain? Paige?
Negative infinity, positive infinity.
So Paige said negative infinity to positive infinity. What other way could we say that? All real numbers. So either one works. So the graph starts at negative infinity because it's going to continue to get wider and wider and wider. It goes all the way to positive infinity, or we could say all real numbers. Either one of those would be acceptable. How about the range? So thinking vertically. Aaron?
I said less than or equal to 4.
What's less than or equal to 4?
Y value.
The y values, yeah. So the y values are less than or equal to 4. And that's because this point here, the vertex, that's its max point. It doesn't go any higher than 4, but the graph is less than 4. So it's equal to it because there is a point there. Any questions with the first one? So the second one, we're going to just keep as a bunch of points. Is this one a function? No. So not a function because at -1 on the x-axis, it has 2 y values. So that x value would be repeated. How would you write the domain? Sarah?
Would you put those like squiggly?
Yeah, those little squiggly things. And what would the domain be then?
-3, -1, 1, 2.
Great. So the domain in this case, because it's just points and there's nothing connecting those points, it's just the values for x. And then Sarah, the range would be?
That would be -3, -1. Yeah, -3, -1, 0, 2.
And then again, we said it wasn't a function. So because it's just a collection of points or a set of points, we don't say y is greater than or equal to, y is less than or equal to, because it's not connecting them. So instead we just put them as a set in those little brackets, little squiggly brackets. The third one here looks like maybe it could have been a parabola that got lazy and it wanted to take a nap and fell over. Caitlin, is the third one a function? No? Why not? Yeah, it doesn't pass the vertical line test. So this graph represents Isa in first period.
Oh, yeah, it actually did.
Taking a nap during
Yeah, I
the
was
movie.
like,
Yeah. So, not a function. Caitlin, what do you think about the domain? So, one of the two is all real numbers, not the domain. The range is all real numbers in this case because vertically this is going to get wider and wider and wider, and it will stretch vertically. So the range will be all real numbers.
X is greater than or equal to 2.
So Sarah said x is greater than or equal to 2. This point right here is its starting point. And then it continues and goes forever to the right. So x is greater than or equal to 2 because those are all the values that are defined for the x. It's not on the other side. On -2, it's not to the left. It's not on the left of +2. So that's why it has to start at 2 and then it goes bigger than. Any questions with those three graphs? All right, so what we're going to do is we're going to try and take this information and write it a different way. Because these are inequalities, and now that we're halfway through the year and starting to really approach the higher levels of mathematics, we really don't write domain and range using inequalities, and you'll never see them written as inequalities again. So any math class that you take will use something called interval notation. So interval notation is just another way of writing domain and range. But it's without the inequalities. And I actually think it's easier. But if you look underneath, we have these brackets and parentheses around different numbers. So interval notation, there are two different things that we're going to think about. If you have brackets versus if you have parentheses. So a bracket in the interval notation is the same thing as having the equal to bar in an inequality. So if it's equal to it, that means it's a point on the graph. So brackets mean that you have a point on your graph. That's a closed circle. So think like when there's an equal to, we usually have either a solid line or a closed circle. The parentheses would be the open circle that is not included on your graph. So anytime you have just less than or just greater than, that's when we would use parentheses. So open circle, because the point is not included on the graph. So that's what less than or greater than actually means. It means it gets really close to it, but it doesn't include that specific number. So less than, greater than for the parentheses, less than equal to, greater than equal to for the brackets. So interval notation, the reason we kind of use it instead of using the inequalities, it actually, I mean, it's less writing because you're not going to write those symbols. But it kind of gives you like a flow of the graph, where it starts and then how it moves to its stopping point. And we use it more and more, and you'll use it for other things as well. So not just domain and range, but you'll be interpreting graphs later on, and you will be using interval notation for that. So it's not only applied to domain and range. Virginia?
Do you do this for like number 2, maybe with the dots?
You cannot. So it has to be a graph that's continuous, so that flows from one point to the next. If it's just a separate set of points, we can't write it in interval notation. So interval notation must have at least one point connected to another point in order to use it. So there's 4 different options underneath. When you're looking at these two numbers, the one thing to remember is that you have to start with your smaller value and end with your larger value. So A is always the smaller or the smallest number. And B is the largest number. Every single time. Because you're starting on the left, you're going to the right. Or you're starting on the bottom, you're moving to the top. So you would never write like 8 as A and then 3 as B. So numbers increase from the smallest to the largest. When you're writing the domain and range, you're going to do the same thing. So if I have an interval notation that looks something like this, so that means that A and B are points on the graph. As an inequality, it would mean that A is less than or equal to X, which is less than or equal to B. So that's what it would represent as an inequality. So it means it starts at the number 3, and then it goes to the number 5 and stops. So A starts, B is where it stops. With the parentheses, the only difference is that it would just be less than. So it's still going to start at A, but A isn't a point on the graph. It's an open circle. And it's going to stop at B, but again, B isn't a point on the graph. It would represent an open circle. The other two options is when you could have like part of one and part of the other. So the first one says if there's a bracket around the A, that means the A is equal to that value. Like there's a point at one space or at one value. But then the B has an open circle and that point doesn't exist. And then opposite for the other one, so if there's a parenthesis with the A doesn't exist, but the B does. So I think once you look at the graphs, like it really does make sense to write it in interval notation because you're just looking at like a starting and stopping point. So what we're going to do at the bottom of the page is go back to these 3 graphs and try and write it in interval notation. So if you go back up to number 1, you can write yours down below, but just so that I have a picture here. We already wrote this domain in interval notation. I can't remember who gave it to me. Paige, did you give me the domain for this one? Maybe? Yeah, I think so. So this one's already in interval notation. All real numbers can be written as negative infinity to positive infinity. So anytime you're thinking that the domain or range should be all real numbers, we're going to be writing it as negative infinity to positive infinity. Because that would be like the flow of the graph. It's starting at negative infinity, it moves all the way to positive infinity. These get parentheses and not brackets because negative infinity is a number that continues on and on and on forever. And there really isn't a value that we can associate with negative infinity. So it never gets a bracket because it just goes on forever, it doesn't stop. The range we said was y is less than or equal to 4. So now thinking in interval notation, where does it start? How high does it go? Sam, can you write it as an interval? So how far down does it go?
Negative infinity.
Negative infinity, so it's starting at negative infinity, and then how high up does it move to? 4. Okay, so now we have to decide what goes around those values. Sam, what do you think?
Let's see.
So I agree with one parenthesis because negative infinity really isn't.
Oh, sorry. One parenthesis and then we would put a bracket.
Right, we would put a bracket with the 4 because it's a point on the graph. That's the maximum value. It's stopping there. So that's in a case where we have like a parenthesis on one side and a bracket on the other. So as Sarah said, interval notation does not exist with ordered pairs. I think it goes there. So there's no interval notation to write when it's just a set of points or a listed set of points. So it can't do it for the number 2. But then if you look at number 3, so this domain we said was x is greater than or equal to 2. So Kate, what do you think for the domain if we try and write that as an interval?
Would it be parentheses and infinity, and then 2 with the bracket?
Which one of those numbers are bigger? Infinity. So the bigger number we want on the right.
Oh, I'm sorry.
That's
I didn't
okay.
read it that way.
And then the smaller number where it's starting is the 2. So we want to start with the 2 because this is where the graph begins, and then it continues on to the right. So the first number is 2, the second number goes to infinity. And then what did you say around them?
The 2 gets a bracket and the infinity gets parentheses.
Right. And then we said all real numbers for the range, which is really negative infinity to positive infinity. Any questions? So we're going to practice 6 different graphs. I think the first 4 are pretty straightforward, and then the last 2 are a little more interesting. Using the given graph to determine the domain and range for interval notation, and then also determine if your graph is a function. Bless you. Thank you.
I think.
All right, Izza, is this one a function?
This is not, yes, a function.
Yes, it is a function. Do you think you could try the domain?
Yeah, the domain would be, I don't know what number that is. It's the 1, 2, 3, 4, -7
So -7.
to 3.5.
It goes up higher.
Is that not right?
What's the x value of this?
Oh, yeah. Sorry, okay. 4. 5.
5?
Yes.
This graph is
So I know the graphs are hard to read. I was hoping it looks a little better on your paper.
It is 4, not 5.
Is it 4?
Yeah.
One,
I go 4,
two,
but everyone's
three,
on
four,
Lewis roll.
five.
so it's
Oh.
5.
I got 5.
4.
We put brackets around them because they are points on the graph. So they get a bracket. How about the range? So looking at the bottom of the graph to the top of the graph, what would you say the range is? Oh, Sam, you ready to answer?
Sure.
Sure.
Yeah.
How far down does the graph go? How low does the graph go?
3.
3?
Negative 3.
They're going lower than -3.
Oh yes it does. It goes down to -4.
It does go down to -4. That's still a point on the graph,
Yeah.
just because they don't have it as an endpoint. It's still that's a minimum value of that graph. So that's a -4.
Then the highest would be 5. Wait, no.
I got
4.
4. Okay, so what goes around those two numbers?
Brackets.
Brackets. So brackets go around both of them because they're both points on the graph. Even though this minimum doesn't have a point that's like specified there, it's still a point on the graph because it's part of the minimum value of your curve. So -4 to +4. Sorry, the graph is hard to read. All right, so Ka, if you look at number 2, is this one a function? Yes? What's the domain for this one? All real numbers. So how would you write that as an interval? And then positive infinity, right? So parentheses around negative infinity and positive infinity. How about the range, Ka? How high was this go? What's the tippy top of the graph? Is it 2? Oh, yeah, it is 2. And then what's the lowest point, Ka? Negative infinity, right? So negative infinity and then 2. 2 is the maximum of the graph. So again, even though there's not a point like specified there, that's still the maximum of the graph, so it gets a bracket. Questions? Alright, so looking at number 3. So this one has an actual open circle in the graph. So there's that little open circle, it's called like a hole or it doesn't really exist. Is this one a function? Yes, it is a function. It passes the vertical line test. Anybody want to try the domain? Sam?
Okay, so wait, domain's the x, right?
Yep.
Okay, so -5.
Yep.
And then it would be positive infinity.
Right. Parenthesis around the infinity, parenthesis also around the
Why not
negative 5.
brackets?
Because the hole in the graph, or the circle in the graph, means that that point doesn't exist. It gets really close to it, but it's not an actual point on the graph.
Okay.
Ethan, do you know what the range is?
Yes.
What would it be?
It would be 3
Mm-hmm.
to positive infinity.
To positive infinity. And again, around both those are parentheses. Alright, is number 4 a function? No. That one is an oval, it doesn't pass the vertical line test, but you still can find the domain in the range, because it still has a starting and stopping point. Erin, do you know what the domain is for the number 4 graph?
It's -1 and 9, and -1 is bracket, and 9
Is
also bracket.
Also a bracket. Good. How about the range, Erin?
It's 1 and 5, and they both have bracket.
Perfect. 1 and 5, and they're both brackets. Alright, questions on those 4? So then if you look at the graphs underneath, these are a little more interesting because they're not like one continuous piece. There's a couple of different pieces to look at. So is it a function?
No.
No.
Yeah.
Yes.
Yes, when they're on their own.
No.
I don't know.
Okay, so
Oh.
But it's an open dot.
Yes.
It doesn't actually go through.
Hey, but look, bro.
so if you look at the 2 points that we're like kind of concentrating on, if the one is an open circle and the other one is closed, that means this point doesn't exist. That's what an open circle means.
Wait,
Is
so
there
I
line
can have line
segments?
segments as long as you know lines exist, knows lines exist.
I don't think the little ones. Oh,
It's just
Great.
because they're on both those last 2 graphs.
Great.
It's just
Oh,
neat.
really?
Oh yeah, oh it is just the background.
Is it like a lot of the X-axis?
Yeah,
There
is.
is.
Is there, or is that?
This is not. This is just the y-axis, so there's no lines connecting it.
But it looks like there's lines in it.
So from these 2 points right here, there is nothing connecting those 2 points. That's just the y-axis. So this is a function. It does pass the vertical line test. Here's a point, the one underneath it is not. And again, this is just the y-axis going through those points. So there's nothing connecting the point at 0 to the point down at -3. So what would the domain be? Paige? Right, it is negative infinity to positive infinity. Because it's going from negative infinity and then stopping at the x value of 5, but then that other piece down below kind of continues on to the x value of 0, and then my third piece continues on to infinity. So when there's an open and a closed circle, once the circle is closed or the point is closed, that's a point on the graph. So it kind of overrides the open circle. So that domain would be negative infinity to positive infinity. How about the range? Virginia?
Would you have 2 ranges?
You would need 2 ranges because there's no space in between that horizontal line and the 2 above. So what do you think for, like, can you give me the range of the upper part?
Would be 0 to positive infinity.
So the upper part is 0 to positive infinity. 0 gets a bracket because one of those 2 points on the x-axis is closed. So it does hit 0. What's the only other number that it touches then for y? -3. So that -3 just gets written by itself instead of those squiggly little whatever they're called.
Wait, why?
Because it's only -3 for that one y value. It doesn't connect to anything else. So this horizontal line, y is just equal to -3. And it never connects to anything else. So that's why it has to get written by itself. Questions? So the last one, we have a circle, and then we have a diagonal line. So is it a function?
Yes, and.
No.
No. So you have to look at the graph as a whole. Yes, the one side of the graph is and the other isn't, but they're graphed together. So this is an entire function. When we were graphing those piecewise functions, like way back in chapter 2, this is what a piecewise function will look like. It's still a function, or in this case not a function, but it's still like a piece. So together, no, they're not a function. How about the domain? So think, where does it start on the left? Where does it go to on the right? How many domains are you going to need? 2. So Ryan, can you give me the domain for the left circular looking shape?
Negative 8 and -1.
Good. And they get brackets. And then the other one, Ryan?
2 positive
And then what did we get with those? Parentheses, yeah. So the 2 gets a parenthesis because there's a little open circle there. And then what about the range? So looking at this graph, from the bottom to the top, what's the range? Kate?
Would it be -2 and 5, and then 2 and then to
So-
Infinity.
My daughter actually wanted a Buzz Lightyear action
Really?
figure for Christmas. I don't even know why, but she wanted like a $60 Buzz Lightyear. She didn't get it. That was, I was like, you're 10, and it's just gonna sit in a box somewhere. Like, no, like, who knows? I don't even know why. Like, so she didn't get one because I thought that was a stupid gift. And Santa also thought it was stupid.
Yeah.
So, all right. So I agree with the -2. Little side thing there, Buzz Lightyear. So Kate said up to +5, and then she gave me a second one for this second line over here. But it goes to +5, and then this line picks up at +5 and continues on. So you only need one range, and that range would be from -2 to +infinity. And the -2 gets a bracket. So starts at -2, even though there are 2 pieces here, those domains overlap. So I don't need 2 domains because this point kind of picks up on that line and continues on. Questions? Okay, so the last little piece on this page, or on the next page, again is a little bit of review. We have not done a lot with evaluating functions. We've been so focused on solving functions or reducing functions. So we are going to go back to like looking at function notation and trying to evaluate them. This one's just a little review. When you have an f of 2, what does that mean you're supposed to do? How do you evaluate f of 2?
Plug it in.
Plug the x in, yeah. So the 2 represents your x. F tells you which function to pick. So I'm picking the f function, which says 4 times x minus 10, which is really 8 minus 10, or -2. Do you divide to get an f by itself? No. That's just notation saying I plugged a 2 into the f function and we got out a -2. So the input, the output, I could really write it as an ordered pair if we wanted to. So see if you can evaluate the rest of those functions. They won't take you very long. make sure you're picking the right one, but you're just plugging in the number for the given function. So Kate, for B, you got?
I got 1,
And what'd you get for C, Kate?
negative 53. Wait, I think I read it wrong. Yeah, I did. Sorry. Hold on. Negative 7.
Yeah, -7. All right, the next row. Isabella in the back, what do you have for the next row? -18. Sam, what do you have for E?
For E?
Yep.
I have -1.
-1? Are you sure? You're so close.
I'm actually gonna go with,
Well, positive one.
it's positive one.
Yeah, so -2 squared is 4, times 2 is 8, minus 7 gives us 1. And then, Grace L, how about letter A, or letter F? H of -2.
So, it'd be 3 minus 5 and -2 parentheses.
So if you multiply -5
Oh,
times
sorry.
-2 first, what do you get?
That gets 10.
And
3 plus 10, H of -2 is 13.
letter G, if you plug in a 0, this goes away and you just get F of 0 is -10. And then the last one, this one's a little larger. What's G of 6 equal to? Aaron?
65.
It is 65. So the homework worksheet, this should be pretty straightforward. I mean, you've got 12 graphs, and these graphs look pretty easy. There's no graphs where you have 2 different shapes on one grid there. And then 13 and 14 are 2 word problems. And it asks you to find a reasonable domain and a reasonable range. So when you're thinking about a word problem, any application has to be positive. Like, you can't have a negative amount of anything when it comes to the real world situation. So try and think about what they would be in context to the problem. Don't just skip them because they're word problems. So like, logically think about what has to happen with the numbers in the case that you're given. Questions?
Somebody, anyone?